Hello, and welcome to today's webcast, Veritas NetBackup, Making Storage Lifecycle Policies Work for You, brought to you by Datalink. My name is Danielle Moore. I'm the Marketing Manager at Datalink and will be your moderator today. Before we begin, I wanted to cover a few housekeeping items. This webcast is designed to be interactive between you and the presenters. The webcast console you are looking at can be completely customized. You can resize or move any of the windows that you have open. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. All questions from this webcast will be captured. If you are experiencing any technical difficulties, please visit the webcast help guide by clicking on the question mark icon below the presentation window. The help guide covers common technical issues. I would now like to turn over this presentation to our presenter, Jeremy Jones. Jeremy, the floor is yours.
Thank you, Danielle. Hey, everyone. I just want to say thank you for joining us today here. We're going to be covering storage lifecycle policies. A couple of things we'll be looking at are some of the basic options you can use when setting up storage lifecycle policies. We'll be covering auto-image replication, what it does, what it doesn't do, and how it can really benefit you. We'll be covering some of the best practices along with optimizing those, and then, of course, tuning your SLPs to get the best performance out of your hardware. So let's go ahead and get started. I think the first question that we need to answer in a situation like this is, what is an SLP? And it's really simple. An SLP is a storage plan for your data after you've backed it up. So, you've run your backups and everything's good, status 0, and you have data. Well, you don't necessarily want to keep it on the same storage unit all the time. You might want to move it from a higher capacity, lower performance to a higher performance, lower capacity, or vice versa. So an SLP really helps you manage what you want to do with your data after you've backed it up and how you want to store it with retentions and everything else to make your environment work. So a little bit of history on the SLPs. They were first introduced in NetBackup 6.5, and they were partially designed to replace vaulting. One of the big issues with vaulting is that an image, if it misses its vault and it expires before the next vault, then you can actually lose data without being vaulted. So SLPs were designed, for the most part, to fix that issue as well as add a lot of other options. It really makes your data management a lot easier. And one of the benefits is that you can have a single SLP apply to multiple policies. So you could run one SLP, have it apply to 50 of your policies, and then make a single change, and that change is, run across your entire domain. So the first few things we're going to cover are some of the basic options you run into when setting up an SLP. This is a common SLP window. Anyone who's ever set them up has probably seen this window or something similar to it. As you can see, you have a backup going to an advanced disk, and then it duplicates to MSDP, then it duplicates again to tape. Pretty common scenario, but there's a couple of things in this that I want to go over that are very specific that a few people may not know about. The first thing that I want to cover is the indentations you'll see. If you look on that far left window that says Operation, you'll notice that the backup option is not indented at all, while both duplication options are indented a single time. What these indentations mean is they show you where the source copy of an image is going to come from when it's being duplicated or replicated. The way it works is that the image is replicated or duplicated from the source that is the previous indentation. So in this scenario, you have a backup going to an advanced disk pool, and it's then duplicated over to MSDP. It's then again duplicated over to tape, but the tape duplication doesn't come from the image on the MSDP pool. It actually comes from the image on the advanced disk pool. This can be a benefit because advanced disk tends to have higher read and write speeds than MSDP since there's no deduplication going on. Another option you might regularly run into is an SLP window. This can actually be very easily missed since it is a different tab, and setting up SLPs, a lot of times people will just set their replications and duplications as needed and go about their business. But SLP windows can be really useful. because what you do is you specify a time when the SLP will actually start to duplicate or replicate. And with each step of the SLP, you actually can set a different window. The downside is that you do have to set your window for every step, but it gives you a lot of freedom and flexibility, and it really helps you separate your read and write operations on disk pools, which we'll get a little more into later. So this is what your SLP window options menu looks like. It's very similar. If anyone set up a policy before, I'm sure they've seen something similar to this. You have your days of the week and your hours of the day. You pretty much set it up exactly the same way when you want the window to open and when you want it to close, and then you can save it. As you can see in this window here, I have actually set it up so that the SLPs will only run between 6 a.m. and 6 p.m. on any day of the week. It will not run any other time than that. Again, we'll get into why I've set it up this way a little bit later on, but this can be really beneficial when it comes to synchronizing your reads and writes. As I mentioned before, you can have windows that are set to specific steps. So you can have a different SLP window for each step of your SLP. As you can see on here, the backup doesn't have a window because that actually falls into the range of the backup window on the policy. But the first duplication, the window I've assigned it, I called day. The replication I've called night, and then the following duplication is called day. The night replication is just the opposite of the day one I showed you a minute ago. Instead of 6 a.m. to 6 p.m., it goes from 6 p.m. to 6 a.m. Again, you can set this to anything you want. This is just for demonstration purposes that I've set this. So some of the benefits here, once you have your windows created, just like with SLPs, you only need to make one of each window, and then you can apply it to any step of any SLP that you have. And it can make the optimization really, really easy. And it gives you a lot of flexibility, again, with your disk pool utilization. The next thing I want to talk about are the retentions. Again, this falls under your main options, but there are a couple of different retention types, and I think most people tend to only use a single retention type. The first type of retention and most common type is the fixed retention, and anyone who has set up an SLP has used fixed retention before. It's extremely common, and it's very simple. You set your retention period, in this case 2 weeks. During that 2-week period, your image is available. After that 2-week period, your image expires. Simple as that. It's really useful when making basic SLPs, but there are a few downsides specific that you don't have any intelligence going on behind it to perhaps expire an image a little earlier or a little later as needed. So the benefit is, you know exactly when your image is going to expire, but you may run into a situation where, oh, an image has expired and I kind of wanted it for another day or two. In that case, if the image still exists, you would have to do a phase 1 and phase 2 import. So there's some downsides to the fixed retention. The next retention type I'd like to talk about is expire after copy. This is one that you don't see very often, but it's incredibly useful. And what it does is when you have a backup or a duplication going to a disk pool, if any images are being copied from that disk pool, it will simply wait until all of the images are copied and then expire the image on that disk pool. So what you can do is use this on a high-speed, low-volume disk pool to increase your backup speed. It's great for flash pools and advanced disks. You essentially use it like a cache to increase the speed of your backups at the cost of your SLPs later on. The third type is called capacity managed. And this one is a little more complicated. It's actually come from multiple different iterations of NetBackup. And it's got a long history, but it's one that is almost never seen anymore for a couple of reasons we'll get into in a minute. But the way it works is similar to fixed backup retentions or SLP retentions, you have a minimum caching period. However, unlike with fixed, an image may not expire once that caching period is completed. It may continue to be available for days, weeks, or even months, depending on how large your disk pool is. What it does do is when it starts to expire images, it waits until the disk pool has reached the high water mark of volume. A lot of times you see 90 or 98, depending on the type of disk pool. But once it reaches that high water mark, it does the expiration in 2 passes. The first pass is going to go through and expire every image that has gone past its caching period. And it does this until it reaches the low water mark or until it runs out of images. Pass 2 comes into play when it has expired all of the images past the caching period, but it still is not past the high water mark. So in that case, it keeps removing images until it reaches the low water mark. These images actually may not be past their minimum caching period. However, the way it manages this is any images that have a duplication or replication coming from them, it will not expire. It only expires images that have performed all of their duplications and replications. This can be dangerous because a lot of times it can really give you a bit of uncertainty on when your image is going to expire. But it can also be really helpful because what it does is prioritize the disk pool health over image retention. Because a lot of times disks need that extra space. The high water mark is set there specifically so those disk pools can do cleanup jobs and keep themselves healthy. The capacity managed ensures you continuously have that space so that your disk pool doesn't ever go into an unhealthy state, but you have a bit of issue with image expiration. So this tends to be good for smaller to medium environments where you can keep a close eye on it and make sure it's not expiring any images that you don't want it to expire. The next option isn't really a retention, but it's an option you can do with them, and it says the postpone creation of this copy until the source copy is about to expire. It's fairly self-explanatory, but in short terms it works as if you have an image with a 1-month retention, near the end of that 1 month, once it's reached almost the end, it will then start to duplicate to the next step. This is good if you have a lot of images and not a lot of storage space overall in your environment because it can help you from having overlap. Having an image on a disk pool versus on tape, there's no reason to have it on both at the same time. So that's where it can come in handy. It doesn't work with expire after copy, and the reason for this is pretty simple too. Expire after copy waits for the replication or duplication to be done before it expires, and this waits for the expiration before it does the replication or duplication. So you'd run into a stalemate and the image would never be copied over. One thing to note, though, is this shouldn't be overused, and it's really better for less frequent backups and, again, smaller environments. A good example of this is if you have SQL servers that need to be backed up 24 times a day, once every hour. If you have that over the course of, say, 30 days, 24 times 30, and if you have 10 SQL servers, multiply that by 10, suddenly you have 7,200 images that are not expired yet. And while this doesn't necessarily cause a problem when looking at what images to expire, it does slow down your SLP process because it has to read through every single image. It doesn't necessarily create a backlog, but it slows down because it has to make sure everyone is ready or not ready to expire. And so you can really see your SLP process slow to a crawl, which is why we recommend, again, only for smaller environments, and again, if you can keep an eye on it. There are a couple of warnings here that we really want to talk about. An image retention is only applied when the SLP completes. Until then, the retention is infinite. This was added in, again, to address what I mentioned before about vaulting, where if an image expires after it's missed its vaulting chance and before the next vault cycle comes, that image is gone. Unless you have it on tape and can do a phase 1, phase 2 import, you've lost your data. And so if you have an SLP that is failing and you've been troubleshooting it for 2 or 3 weeks, if the expiration on that SLP is only 2 weeks, you'll still have the image. It won't be expired while you're doing your troubleshooting. But a common troubleshooting step is to manually expire and then manually duplicate again. And the problem you can run into here is that if you have been working on it and it's past what its original intention, past what its original expiration would be, then you run into the issue where the moment you expire it, or I'm sorry, not the moment you expire it, the moment you cancel the SLP, the image gets expired. So that can lead to data loss, and we've seen it happen, and it's really bad because you're working a case and then all of a sudden you lose your data. So you really want to be very careful about that when performing troubleshooting on SLPs because, again, the retention, once it's applied to the point when the image was backed up, not applied when the SLP completes. Something else to be mindful of is SLP version. So what we mean by an SLP version is when you create an SLP and hit the Save button, that's the first version of that SLP. Any images backed up with that version will, throughout the entire life cycle of the SLP on that image, they will follow the steps in that SLP. Now, if you go back into that SLP and make any changes, it will then save it as version 2 of that SLP. So what this means is that if you have, 500 images that have an expiration within a month and you want to extend them, you can't just log into the SLP and change it to 2 months or 6 months or a year. You actually have to go in and change the image. So those original images will always follow the original SLP version path, even if the SLP has since been changed. The next thing I want to talk about is error. And error is fantastic. I think there's a lot of situations where error isn't used that it really should be. So the question is, what is error? What does it do? Well, error is master server redundancy. The idea is that if your master server is down or destroyed or deleted or something terrible happens to your master server, through standard duplication, you can only recover images or perform restores if you've either A, fixed that master server and restored the catalog to it, or B, aired the images over. Now, I've seen situations before where people have had environments, both a production and a disaster recovery environment, and what they would do on their disaster recovery environment is have a master server at the same version and with the same host name as their production master server, and they would take tape backups of the catalog of their production master server, carry them to the DR site, and then perform an import and restore of those images onto the DR master server. And that's way too much work. So the benefit of error is that it sends the image and the catalog data to another NetBackup domain, and then using the catalog data from the first domain, it rebuilds catalog data for the second domain via a process called fast import. The easiest way to think about this is it uses the data from the first catalog to fill in the blanks for the catalog information on the second, and then just changes what it needs to change to make it work with the new domain. The benefit here is that it allows a restore even if a backup master server is completely down. When an image has been aired over to another domain and to another master server, as far as that master server is concerned, the image was backed up by that master server, and it can do any restore operation you want it to do. Another benefit of auto-image replication is called optimized duplication, and that may be supported by your storage unit. So what optimized duplication does is it has the same principles as deduplication, and it increases the data volume that's being transferred over your network so that you get faster transfer speeds and you don't do as much to bog your network down. And we'll cover how deduplication works here. So basically what deduplication does is break an image into different segments, which are then assigned a unique value. And any identical segments, they're only stored once. So you can see in the image below, you have your backup image on the left. Then in the middle, you have every segment that makes it up. And if you notice, there's only 3, A, B, and C. And the whole image is made by multiple variations of those same segments, just in a different order. So when you're storing the image, why do you have to store the whole image if you can just store one of each segment and then keep a database that tells you which order to put them in? So that's what a deduplication engine does. It can be really useful, especially with something like Windows backups, where you're backing up the operating system every day on any, upwards of 500 or more systems. And why do you need to store Windows system files or even Linux system files every single time for every backup image? So deduplication can be really helpful by removing the excess data and only storing the image segments. So that's really where deduplication comes in. Optimized duplication works a little bit differently, but it has the same principles. So with optimized duplication, what you're doing is with both the source and the destination pools, they will both be deduplication pools. It takes the image segments on the source pool and it creates a checksum from those image segments. It then sends that checksum over the network to the destination pool. And if they find a match on the destination pool, then they don't transmit the segments. There's no need to. So the benefit here is that when you're performing even a full backup and airing the full backup over, the only information that gets transferred is the changes. And this doesn't even happen at file level. This actually happens at segment level, smaller than file. So you could have a text file that is backed up every day with information added to it every day, and throughout the days, throughout a month, the only changes are going to be the final text file, but you have the engine data in the deduplication database to recreate any file from any day of that month. So that's where deduplication comes in. It really, really saves you on storage space. There are a few things to note about AIR, though. Specifically, it only supports MSDP to MSDP replication. That is the only thing it will do. And you have to have both an SLP on your source and master servers. Both SLPs have to have the same name. The master servers have to be trusted master servers, and the target destination storage actually has to be added to the source as a target destination storage. Once you do this, you will have to create the import step on your target destination first. Once you've done that, then you can go and create the SLP on your source and point it to the import step. The benefit here with AIR is that it can be really integrated into existing SLPs. You can add an AIR step into any SLP you have, really, as long as you've set it up with trusted master servers and a target destination source. So here's a picture of a couple of AIR SLPs. As you can see, the first one was the export SLP. You actually have to create the import first, but for the sake of understanding the process. So in this case, we have a backup that's going to an advanced disk pool. It's then duplicated over to an MSDP pool. And then from the MSDP pool, with that being a deduplication pool, it's replicated over to the target, which is on the import. And now you can see on the import SLP, the first option is an import job. With SLPs, you always have to have a backup as the first job, except in the case of AIR. At that point, you will have an import as your first. Then on the target, it's duplicated from the import MSDP pool over to tape. And on the source, it's duplicated from the backup advanced disk pool over to tape. Remember, keeping into account what the different indentations mean on the side of the SLPs. So this is just a common setup. You can do really any number of things with this, any way you want to store your data. But again, the benefit is that on the import side, if the source side is completely destroyed or wiped out or just unreachable, you can do any restore straight from that import side. So a couple of notes here when comparing duplication and replication, because they are two very different things. Duplication will be within a single NetBackup domain. And when we say NetBackup domain, we mean a single master server and any accompanying media servers. So with duplication, you'll have multiple copies of an image that are on different storage units, but are all tied to the same master server. And that master server will contain all of the catalog data that's needed to perform a restore from any of those multiple copies. With replication, you're going across NetBackup domains. And again, I mentioned this before, but the idea behind replication is that you're providing master server redundancy versus duplication, which is storage unit redundancy. So that's really the difference there. In duplication, if you lose the storage unit, you can still do a restore. In replication, if you lose your master server, you can still do a restore. So now we want to look at some of the best practices and tuning to get the most out of NetBackup. The first thing you want to do when setting up SLPs is implement them slowly, 1 or 2 SLPs a week, just to see how the image is processed, to make sure you have the room in your environment, the processing power, the storage, the network capabilities to process your SLPs. Because the last thing you want to do is set up, all 10, 20 of your SLPs, leave it for a week and come back and have a backlog of 5,000 images and, wonder how you're going to get these SLPs, these images duplicated over. So that's one of the things you really need to do is just implement them slowly, keep an eye on them, and make sure you don't overtax your environment. Another thing you can do is limit the communication between servers to only what is needed. A master server should really only need to talk to its media servers, and it shouldn't need to talk to any other media servers. And what you see happens is with extra communication links, you have master and media servers that are constantly trying to keep in contact with each other, which can put a lot of chatter on your network. But one of the problems is that if you have 3 master servers for 3 different domains that all connect to the same media server, if any one of those 3 links go down, then in EMM, it will mark that media server as down, and it will kill any jobs going to that media server, even if it isn't down. The only thing that escapes this really are any jobs with what's local to that media server because it's local. Another thing you can do is utilize the alternate read server to help prevent data retransmission. So something you can see with duplications, if you have an image duplicating from one storage unit on one media server to another storage unit on another media server, if both media servers can access both storage units, then you can have a situation where it's actually reaching to a media server across the network to do a duplication to get the data, and that can really slow down your SLP if you do that. So utilizing an alternate read server, you can force it to use either a local or a high availability media server that really will give you better performance than reaching across the network to grab a media server that's over on maybe a 10 meg line. Something else to note with SLPs, basic disk is not supported in any way. The only way you can even make basic disk work with an SLP is if you put it into a storage pool. But even then, if you point your SLP to a storage group and it's got nothing but basic disk in it, your deduplication is going to fail. So that's just one thing to be aware of. You have to use either advanced disk or MSDP or some other form of medium that is not basic disk. A couple of things to note about tuning. You've seen a lot on any of the images. I always have the backup going to an advanced disk pool. And what I've done in a lot of those SLPs I've created is I utilized that expire after copy option, and I'm using the faster read and write speed from the advanced disk pool to essentially give me a cache before I copy it over to my slower tape or slower MSDP pool. The reason advanced disk is faster than MSDP is because the image is written sequentially and it's read sequentially. You don't have to worry about rehydrating, which is rebuilding your image from the segments on an MSDP pool. Rehydration is extremely CPU intensive and it's extremely disk input-output intensive, so it can really slow down duplications while it's trying to do that. So I utilize an advanced disk pool which doesn't have that much storage space in it, because it's only needed for a short time with any image before the images are expired. So the backups, that's what they do, is they go to the advanced disk, get copied over, and as soon as the copies are done, they're expired from the advanced disk, and I have my duplications on MSDP and tape. Something else you can do is to separate like images into different SLPs. And this won't help with overall speed, but what it'll help with is prioritization. So what I mean by that is if you have 10 Windows images that are maybe a couple of gigabytes apiece, maybe 10, 15 gigabytes apiece, assuming they're small images, and you have a database that is 1.5 terabytes. If they're on the same SLP, even if they're going to the same location overall, which they shouldn't be, but we'll get into that in a minute, then what will happen is it may duplicate the first image and then the second image, and then start duplicating the database. And the third image isn't even going to start its duplication until that database is complete. So you might run into a situation where, yeah, your images aren't very big and should duplicate quickly, but you may be waiting several hours or even a day or more while this database is duplicated before your image even starts. So separating them out into different SLPs for like image types will help prioritize it and make sure that, yeah, your duplication of this database is going to take a day, but you can get these 10 images duplicated right now. Something else you can do is to separate your deduplication pools for different data types so that you can increase your deduplication rates. I touched on this a little bit before talking about deduplication and how if you have a bunch of Windows backups, there's no need to store all of the Windows system data since it doesn't change. So if you combine all of those backups into a single deduplication pool, you'll see really good deduplication rates. Databases tend to not deduplicate as well, especially if they're Oracle, but they will deduplicate better than they would with a Windows image. So again, separating those out can really help. And if you have a file server such as CIFS, going through SIF shares, then those images, of course, would deduplicate on their own pool based on previous images copied to that pool. And something to note about deduplication is that if you have good deduplication rates, then you'll have really good optimized or OptDupe rates. Because again, it only has to compare that data as it goes across the network, rather than sending the entire image across and comparing it afterward. Another thing you can do, and this is really a very useful option for medium to large environments where you're really pushing your hardware as hard as it can go, separate your read and write jobs on a disk pool to help speed up your backups and duplications. So what I mean by this is if you have a disk and its spindle is constantly changing from read to write on the platters inside, then what you have is that it slows down your overall rate of read and write. So if you decide that, hey, on my disk pool 1, I only want write jobs, then you could schedule your backups to go at night to the disk pool, and any duplications that are going to that disk pool, you could also schedule at night. This is where SLP Windows come in handy when being used with backup windows. You can actually separate for each step when it's going to be writing and when it's going to be reading on each disk pool. There's an old saying, one bad apple spoils the bunch, and that is absolutely true in this instance. You could have 50 backups being written to a single disk pool, and you'll be having fantastic speed. But if you have even a single duplication or restore reading from that disk pool while doing those backups, you'll see as soon as that duplication starts, your performance is going to go down. So even a single duplication can really mess this up. So that's why it's really important to make sure you separate these out. And again, you can really do this easily with SLP Windows. You can, as I showed you before, I have both the day and night windows. It's very simplified. Some people have more complicated environments. But with those day and night windows, I can make sure that each disk pool will only get either reads during the day and writes at night, or writes during the day and reads at night. The next thing you want to take a look at is being conservative with the number of SLPs you create. The more SLPs you have running, the more that NetBackup has to keep track of as it's doing the image scanning and checking to see what's going on, see what images need to be duplicated or replicated or expired. The more SLPs you have, the slower this process can get. So you really want to stay, only have as many as you need while still following all of the other tuning steps that we mentioned. And you constantly want to be monitoring your backlog and adjusting your SLPs accordingly. A larger backlog doesn't only mean that you have more images that need to be copied or duplicated or expired, but it means that the SLP process has to read through all of those images. So not only will you have more images than you can handle, the larger number of images is going to slow down your SLP process, compounding the problem. So you really want to monitor your backlog because it is a cycle that is really hard to break out of, and it usually involves expiring a lot of images that don't need to be expired. So that's something to be very careful with, is you just want to make sure you don't have a backlog that gets too high. So I want to finish off here. I've just posted some images. You've already seen these throughout the presentation, but I want to go through and show some of the optimizations that I've actually put into these that I didn't talk about earlier. So as you can see on this image here, the first step of this is the backup. And like I said before, the backup falls under the backup window. So we'll assume in this case it was at nighttime. And it backs up to an advanced disk pool. You'll notice the retention type on the right is expire after copy, like I mentioned before. And then the duplication, which goes at the daytime, is reading from that advanced disk pool and copying it over to an MSDP pool, which is then stored for a month for, faster, more recent restores. Then you can see that the duplication to tape, which again is coming from that advanced disk pool, notice the indentations there on the left, the duplication is reading at the same time as the MSDP, and it's copying over to tape as well, or copying over to tape, which then has a retention of 1 year. So that's just one way how you can schedule a standard SLP to really be more optimized in your environment. If you notice, again, it's only writing to that advanced disk pool at night, reading to it during the day, and being sequential. That advanced disk pool is a lot faster than MSDP or tape. So once all the images have been copied off of that advanced disk pool during the day, the image on that pool is expired. And then this here, this is just, again, these are the replication slides that I showed you before. But as you can see, like in the previous one, we start with our backup going to advanced disk. Now the retention period here, I actually, after creating this, I realized I didn't set the retention period, but we can assume it's the same as it was in before, where the advanced disk is set to expire after copy. It's then duplicated from the backup image on the advanced disk pool to MSDP, again, just like before, and we'll just pretend that the retention period there says a month. It's then replicated from that MSDP pool over to the target. And then the target, you'll notice the window on that import is nighttime, which matches up also with the window on the replication. So it reads from the MSDP pool at night, and then the next MSDP pool on the import, it writes to during the day, or sorry, writes to at night. So on the import side, you actually have your schedules flipped. That way you can keep your reads and writes synchronized between the two different domains. Then the duplication from that MSDP pool over to tape happens during the day. And again, on the source side, you have duplication coming from your MSDP pool. Again, notice the indentations there during the day as it goes over to tape. So that way, again, you've synchronized your read writes. You're using the advanced disk as a cache. You're using air to make sure if your first master server gets destroyed, that you still have a method of doing a restore. And then with duplication on the opposite side, you're making sure you're writing to MSDP at night and duplicating from it during the day. There is a couple of things I also want to mention before I close this out here, specifically with replication compared to the scenario I mentioned before, where a catalog was being transferred from one site to another and was being phase 1, phase 2 imported to the other site. The one downside with replication is that your backup policies are not copied over to your DR site. For a lot of people, that can be a make or break scenario. For me personally, it isn't, because if I'm running both a production and a DR site, assuming my production site goes down, I'm assuming there will also be other systems that are not backup related that go down with it. So my first priority is to get those restored as fast as possible. Once all of the restores are taken place, then I can do a catalog, or either a rebuild of my primary master server, or I can make the adjustments as needed to do a catalog restore. That way, we can get our backups working again. But the reason we use replication is because our primary source, or our primary concern, is to get the production images restored if they need to be. So with that, are there any questions? I guess I'll give this over to the Q&A team.
It looks like all of the questions are being answered in the Q&A widget, so I think if there's nothing else, we will wrap this up. Thank you for attending today's webcast. An on-demand version will be available within 2 to 3 days. You will receive an email notification once the recording is available. Thank you again for participating in today's webcast.